Hello. Um, this is my IoT firmware hacking presentation. I do not have a who am I slide, but you guys know who I am. Maxim Kochnev, third-year cybersecurity student, pursuing a minor in math, and I'm involved in a lot of stuff, ops team, VRIG, eBoard, I'm the IRSEC CA. Speaking of which, everybody sign up for IRSEC, blue team or black team if you haven't already. It's going to be a lot of fun. And yeah, so a little background about what's going to be talked about in this presentation. This is something that I worked on over the summer. I didn't have much time to work on it, but it was something I was doing while I wasn't working my full-time job. So it took a while, but it was a lot of fun. It was really interesting, and I'm excited to share it with you guys. So this is just what we're going to be going over. I'm going to outline, I kind of wanted to make this very organized in the way that I was presenting it and the process that I followed, because although I'm not, this is my like kind of break into like vulnerability research and actually trying to reverse engineer binaries and like exploit things. I kind of wanted it to be the same process that I would follow if it was a more complicated technique. And you'll see this exploit is not very difficult. The kind of process to get to it was a little complicated, but the exploit itself is like one line. However, I thought the process to follow was very useful and I think applicable to a wide variety of these things. So just before we go in, I know a lot of us have like varying levels of understanding about all this stuff. So I just wanted to define a few terms. So in the title, you saw IoT firmware hacking. IoT is an Internet of Things. So these are devices which connect and exchange data with other devices across the network or other communication networks. This presentation, it's going to be on a router that I had. This is a research router that I got from the club to borrow and play around with. And obviously a router is defined as an IoT device because it helps in that communication between the internet or any other network that you're communicating through. Now firmware is the software which is embedded into the hardware. This is what comes with the router, or if you ever heard like of a firmware upgrade, you're updating the software which is embedded into that hardware. So say like a router has a function called WPS, right? You push down a button and you try and connect your phone to it, so it's called a Wi-Fi protected setup. Say there's like a security patch to it. You would do a firmware upgrade to update the software which is interfacing with that hardware. And finally, reverse engineering. This is a big term for just to understand in general as cybersecurity students or just people interested in cybersecurity. Reverse engineering is decompiling a binary to understand how its source is structured. So when I was looking into how this router worked, I didn't have the source code. So I had to get what it was running on to figure out what it was doing, where there are potential holes in its source code, and see where I can develop exploits based off of that. All right, and here's just some goals. Just like I just wanted to make it like a step-by-step process. So first, I needed to obtain the version-specific firmware, right? Because there's different versions. Like I said, there's firmware upgrades. So whatever I download might not be the one that the router is using, so it won't work when I try it on the router. I'm going to reverse engineer whatever I find to be important as part of the firmware to see how the router functions, and based off of that, identify vulnerabilities that can be exploited. All right, so here is the target. This is a Netgear WNDR 3700 version 1 N600 wireless dual band gigabit router. Anything online is kind of open game for this, whether that be like forums of people talking about it. As you can see here, this is off of the documentation that I found on the Netgear website. You see, like later on, we're going to be going into like what are these different kinds of features that it has. This just kind of lists it out for you. So here, like you see all the different like the details of the USB storage itself. We're also seeing like the other hardware that it supports, system requirements. We also have like the product data sheet, all that stuff. And also, when I went on this website, I also went on to I think it was the setup manual, and I found the default credentials, right? So I just wanted to log into this router as a regular admin would and just kind of use it as, a regular person would, and see where some of this stuff is. So if you go into like the system information, I was able to see the firmware version. So now I know what firmware version I'm supposed to download, and now I know where I have to start. Okay, so luckily I didn't have to do much digging. It was like right there on the website. It just downloads, and it goes like it takes you to a specific page, and you click the version and you download it. I don't have to do all the wizardry with logic analyzers and I don't even know all that stuff of actually extracting yourself. I was able to download it. However, when you unzip it, it comes as a image file. So I can't. An image file is basically how kind of hard to I don't know how to describe it. This is how you want the system to be, right? So if you were to do a firmware update, you would put that image over your existing firmware, right? You're not copying each individual binary into the system. So basically, I had to do what is called unpack the firmware, or get the firmware out of the image. That's where binwalk comes in. Binwalk is a great open source tool. Analyzes and extracts files and executables from firmware images, right? So I had my firmware image. Now I have to get everything out of it. I had some issues with it on my regular Fedora system, so I just opened up a Kali virtual machine because I think binwalk is pre-installed with Kali. It had all the dependencies already. And as you can see, when I run this, binwalk tac-e extracts all the known data files like binaries, directories, configuration files, anything that is a kind of well-known file type, it'll extract. And right here, you can see, as a result, we have a squashfs root. When you go into there, you'll see a regular file system. Maybe not as you would see it on your laptop, but this is a file system, right? This is what we are installing onto the router, or what is on the router at the moment. All right, so now we start our actual analysis stage. This is when I actually jump into figuring stuff out about the firmware. So this phase is called dynamic analysis, right? Because I am literally interfacing with the router. I am I'm taking actions on the router as a user would. And yeah, so first I just wanted to enumerate all the different functions the router has. We saw it earlier. However, I wanted to go into the regular, where a user, an admin would actually go to and see all the different things, right? So we have WPS, like I mentioned earlier, where you click down the button and you connect your phone. We got USB settings, remote management, UPnP, universal plug and play, WAN and LAN setup, and also set password, right? These are all potential attack surfaces and things that I'm keeping my eye out for when I I continue to work with the router. These are things that I want to look at, right? What is the functionality that I could exploit? How is it receiving this stuff, and how can I misuse it? So now I started using Burp Suite. If people don't know what Burp Suite is, it's a tool that lets you, in a kind of high level, for what I'm using it for, Burp lets me interact with HTTP traffic, right? So I can see what I'm sending to the router when I do specific things, what the router is giving back to me in a lot, a high level of detail, right? So this, I forget what I did here. I think I clicked on some button to check the language or set the language, and it gives me, this is what's going on under the hood. This is my request, and this is what I get back. And based off of that, I just started looking through some of the HTTP traffic, right? We can see that it's communicating with HTML. We're seeing some details this authorization token. If you were to scroll through each packet, it's using all the same authorization token. Now, although that's not what I'm exploiting in this, that's something to consider, is if you crack the authentication algorithm, then it's basically free authentication. It doesn't change. It doesn't change. It's not any variable thing. Another thing is, this funcs.js, right? So now we know that it's using JavaScript somehow. We also see the server that it's using, UHTTPD. That's a specific binary. which is giving me these specific requests, or is handling it in a specific way. And now, I was just clicking on getting information, like finding these like static like information which was present on the router. What if I try and make a post request, like set a password, right? Because we saw that set password function before. If you look up there, you'll see apply.cgi. CGI, or Common Gateway Interface, is basically how HTTP servers can take a request which a client makes and like kind of pipe it to whatever their program is doing, right? So on the server, on the router, there is a set password program. So the CGI function takes my request and says, okay, you need to do it with these parameters, right? So as you can see, my submit flag, and I just changed my password to like password, right? Just like a letter change, just to show you that this is how it's submitting it to this Common Gateway Interface, and it's actually changing on the router. And this is the final step of my dynamic analysis, is just a simple Nmap scan. I'm just trying to see what services are open to any user that is connected on the LAN, right? So as we saw before, we have UHTTBD. That's what the client was interacting with. We have Samba. We also have Telnet. That was interesting. That's something I tried at some point to exploit, but it was complicated, and I don't think the router was kind of finicky. So anyway, I decided to go with the UHTTPD, right? Because that's what I was interfacing with this whole time. Okay, and now we start our static analysis phase, right? So static analysis is, I'm not directly getting like a response from the router, right? I'm looking at the static information which I extracted, right? So I have my firmware, I have these files which are now on my computer that I can analyze, and then I start my static analysis phase. So I run quickly just file UHTTBD just to understand a little bit more about it. Not unsurprisingly, it is an ELF executable. This is just how you would normally see. ELF is just a type of executable. It's like a standard format you'll see it in most executables. But it is a MIPS architecture. So if you're not familiar with what MIPS is or what assembly is, MIPS is just a different architecture, right? So assembly, you have a set of instruction sets, right, for what the computer is going to be doing, right? It's going to be moving from memory to CPU. It's going to be doing all these things to like actually do what a program wants it to do. MIPS is just another type of architecture, right? It's going to have a whole completely different instruction set, and it has a different purpose. So MIPS, from what I remember, is pretty good with just like networking devices in general. It's supposed to be very efficient, quick. And next, I just ran strings on it, right? So strings will print out all of the readable strings as part of the binary, right? So when you compile it from whatever source code it was to the actual binary, there's going to still be some strings that the developers have in there that were not changed into like your usual like bit code nonsense, right? Because they're still readable by the program. So strings just prints this out, and there was like a lot of output. There was like pages upon pages, but what caught my attention was how much XML content I was seeing. And now, if you're not familiar, XML is it's a way to it's a type of language, but it is typically used to communicate, right? You can define a specific data structure, and you can send like specific data the same way you would see with like JSON data, right? And when I grep for XML just to see some of these individual strings, I'm seeing a lot of like get and set, right? So that's pretty that's good for me, right? Because if I can use a get command, right, I can see some of the information maybe they don't want me to see. Or if I have a set command, I can start playing around with changing configurations to what they're not supposed to be and change access to what I want it to be. And now we're going to start reverse engineering it in Ghidra, right? If you're unfamiliar with what Ghidra is it's a reverse engineering tool which will take a binary and decompile it. So it'll put it into the MIPS instructions, like I said before. It's going to put it into what the computer is going to read, right? Like moving it from memory to CPU, all that stuff that the program would actually be telling the computer to do. But it also has a great feature of making like a source, like showing you the source code of what it should be based off of like these like common instructions. So initially, I put UHTTBD, right, the web server, which I've been keeping my eyes on this whole time, into Ghidra, right? And all these are functions, right? These are like, so at the top you'd see like functions, a folder of functions that start with A, a folder of functions that start with B64. But what really caught my eye was this execute SOAP action, right? Mostly just because of the word execute. Because if I see a function that's like do this, right, and I send to the router something and I was like do that, and it does it, that's a pretty good exploit, right? So that just right off the bat caught my eye. And then I did a little bit of digging into what SOAP was because I'd never heard of it before. And it's a simple object access protocol, which sends and receives messages using XML. So we saw XML before, and that caught my eye with all the get and set. So now I'm really looking at this, right? And if you click on that function, this is what you would see. This is what I said, like the MIPS instruction set and the source code which Ghidra comes up with, right? And it's going to map, you can map this to the source code, right? So if you were to click on, say, this line right here, then it'll like highlight whatever the corresponding like beginning instruction is over there on the like computer, like on the MIPS instructions, right? So I'm also able to see the incoming calls. So what is calling execute SOAP action? And I can see that a function named handle request is calling it. So without much like more digging, just right off the bat, you can think of, okay, this router is getting a request, it's handling it somehow. At some point, it's telling its program to execute this action. So this is further, this is a little like something good for me to look at. I know I'm on the right path. Yeah. And so I'm looking at handle request, and it's like there's a lot. I haven't really looked at how HTTP requests are handled, but I guess this was like doing it line by line, right? It was going through like what you saw before, like with this. It has like a host, authorization, all these headers is what that program right there was looking through, right? And I wanted to see, how do I get to this point? You'll see it highlighted where it calls execute SOAP action. Because at some point, I think I might show it later in the slides, it shows this like SOAP action is true and execute the SOAP action if this condition is true. So basically over here, this is me like running through each like bit calculation that it was doing. Like it would do like check for the string authorization and then like jump however many bits that length is, check for a colon, check for like this like free space. And so I just started like writing that down until I got like a basic understanding of what I was looking for. So from that, I was able to figure out that I needed a HTTP header to make it a SOAP action with this kind of structure, right? Where it has something over here, colon, service, something over here. And then based off of that, I should receive a response with the requested data. And that reminded me of something that I saw earlier. When we were looking through the strings, you would see that string throughout every single XML string you would see, right? You see service, 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 with all this get and set stuff. So, you know, that caught my attention. I was like, I got to keep looking at this. Okay, so now I got to dive into how do I actually get a response, right? Because I could send something, but there's no guarantee that I'll get anything back. So it's time to start looking at the source. Execute SOAP action was kind of nonsense. It was a bunch of gibberish. Ghidra can like read what all this stuff is, but obviously it doesn't know the context of what it's used for. It doesn't have variable names. It'll just say like variable 1, variable 2, And in this case, it's like even more nonsense for some reason. I don't know. I don't understand Ghidra. So I was like, okay, I guess I gotta like look at the MIPS instructions and like do it the hard way. So I was like, okay, I got a little background into MIPS instruction set because it's not what I'm used to. I have like a little bit experience with assembly, but this is different. So I kind of broke down execute SOAP action into two distinct parts. First, I have loading the SOAP actions and corresponding system configurations, maybe. I have a question mark there because that's what I'm pretty sure it does, right? So over here, if you're unfamiliar with assembly, this is like kind of like a move instruction. It's moving what these SOAP actions are into this register. A register is, I guess like without really going into too much detail, is a little, it's something that holds data on the CPU, right? So that means we're going to start doing something, the program is going to start doing something with SOAP actions, right? And if it's based off of that XML data I saw before, that means it's going to start doing something with the commands, right? And I also see this pointer to eater items. Not sure what that is, but it's also using that. And it's checking if over here you see string compares, which is like saying in like a Python program, are these two strings equal? So it's checking for some kind of equivalence in what that header is. And then over here, we're looking at the SOAP authentication, right? So it needs to be authenticated somehow, so it's not just like a bogus request. And we see like anything like I think SOAP auth. I named it that when I was like working on it in the summer because I kind of figured that it was this authentication, so I renamed it in the compiler to make it easier for myself. But that is what it's doing for the authentication. And now, wait, did I miss something? Okay, yeah, I have my slides out of order. So this was going into the SOAP actions that I was talking about before, and you see references to a lot of different data, right? I'm not sure what it is, but I can assume based off of the title of the reference, dev config methods, it's referring to device configurations. So if the SOAP action is like interacting or interfacing with some of these device configuration methods, that would make sense and correlate to what I saw before with that XML data. And over here, we also see that pointer to the eater items, whatever I saw, and references to a lot of these functions. And I didn't put the pictures of the functions, but if you were to go into each of these, you would see a response to what a typical SOAP request would receive, right? And so now based off of that, I made my hypothesis, right? The SOAP authentication will return 0 given no content, right? So I go into the SOAP authentication method and I see this. If authenticate and it's 0, right? String compare, and it doesn't receive that, then it's going to get 0, right? And it's going to return that number. An execute SOAP action will only fail when we return -1. And in between here, this is the function which sends a SOAP response and handles what my command was. So given the right HTTP header, I should get a valid response. And so I kind of just used the string that I found in from when I used strings in my static analysis to, I figured if it's comparing something, it might be comparing based off of that. So why don't I use that in my HTTP request? And sure enough, if I put SOAP action with that string that I saw earlier in when I dump the strings of UHTTPD and grep for XML, I get the password. I get the admin credential. This is the one that we set earlier when we authenticated, logged into the site as like a normal administrator would and changed the password. And here you can just see the password in plain text. You can see the MAC address. And as you can see, I did not submit any authentication token that you would see with regular communication. So basically, this is a authentication bypass where I was able to find the admin credentials. I didn't need to submit any, I didn't have to break any authentication algorithm. And it's also, this is just one of the SOAP requests that we can do. There is like, you saw that strings, like I didn't go into each of them, but there's a whole list of device configurations that you can look at and things maybe you can even set if you find the right body value. So essentially, what I got based off of this is that if you pass it in a valid SOAP action header and you don't have any content in there, as you can see, when I submitted my exploit, there was no content, right? There's no body to the message. You receive a response with the information that you're requesting. And that's my exploit, is I get admin credentials and can be, yeah, it could be a variety of things. Yes, David. Oh, okay. And just a thank you, because I wanted to thank first like a video which I like kind of watched a lot of times just because it kind of outlined this process of gathering information, dynamic analysis, static analysis, like crafting an exploit. I watched that a bunch of times, so I figured I would, like, I'm sure they won't see this, but I figured I would give credit for that where credit is due. Funny enough, when I was like looking at it, writing this presentation again, they like, as an example of an exploit, they like put this like that exact HTTP header. And also all the club members who helped me when I had questions and had the patience to answer my questions. You know who you are. Thank you so much. Any questions? Yeah.
So you said that you were working a job while you were working on this. How much time would you say you spent on this per week?
Yeah, so the question was, I worked a full-time job while I was doing this, so how much time did I spend on this per week? Luckily, my full-time job was completely online, right? So I didn't have like the stress of like commuting, getting back, you know, all that stuff. I was at home, so as soon as I logged off, I had the opportunity to just like, let me just like start working on this for a bit. And it would vary, right? So I would like work on it for like days at a time, like trying to find different things for like maybe like a couple hours at a time. Or some days I would just like forget, or not forget, I would just like didn't want to do it because I was tired. But I would say for like actually like this specific exploit and following through with like identifying the like SOAP service which it's like exposed, and like from that beginning to like actually getting the exploit to work, maybe like 2 or 3 weeks. I'd say like after I like actually figured out, like had an idea of what I was doing. Yes, David.
Where did you get the router that you did all this testing on?
The question is, where did I get the router that I did all this testing on? This was a router which is provided by the club as a research device. So I'm borrowing it from RITSEC, and I got to do a little research project on it. Yes, Garrett.
If anyone wants to do hardware hacking, they should get it from research so they don't have to pay for the router themselves.
Google form opening soon.
Yep. Yeah. You, if you have a idea for a research project and you need some kind of hardware or something you need to buy, take it to the research guy, Will Dandrade. Yes, Scouse. This was a Netgear. It was an old Netgear. Netgear WNDR 3700. Is that yours? Was that yours? Yeah. Yeah, yeah. Oh, yeah. Oh, awesome. Yeah. So yeah, it was good. Also, this firmware is like old. It's like the product reached the end of date. The firmware is out of date. So like, you know, it's not like this shouldn't be a problem. This was also disclosed through like a process, like it was submitted to the vendor. This is why I'm able to stream it right now. I didn't like go through like all like the bureaucracy of it. It was already submitted to the vendor and wherever else. So yeah. Yes, Will.
So you wanted to get into an IoT smart lock, and you didn't want to do all the reverse engineering. What would be the easiest way to do that?
Will, what is a IoT smart lock?
Like, you know, like a smart lock that's like connected to the internet.
I would. Is it a lockpick set?
Oh, maybe it might be a lock.
Oh, it's a
Five
lockpick set.
presentations.
Thank you so much. Thank you, Will.
Well, thank you, Maxim.